Hello everyone and welcome to another video in my channel. We have a polynomial of degree 4 equation to solve. We are given that x is a member of the set of integers. So when we say integers, we mean whole numbers. And we are required to find the value of x. The problem is x plus 1 as a quantity to power 2 plus x plus 2 as a different quantity to power 3 is equal to 2 minus x plus 3 as a quantity to power 4. What should we do to solve this problem? We have a quantity that is raised to power 4 to expand, and expanding it and also expanding this quantity to power 3 will make the work tedious. So what we need to do is to avoid this expansion. A better method is to make a substitution, and that substitution is this. I am going to let y equals to x plus 3. This y replacing x plus 3 will enable me to avoid expanding this quantity, which is to power 4. So if y equals to x plus 3, then y minus 1 is x plus 2 and y minus 2 is x plus 1. So we now substitute this for this respectively and then proceed. So we have y minus 2 squared. This expansion is easier to deal with, plus y minus 1 to power 3. This expansion also is relatively easier to deal with than this expansion, is equal to 2 minus y raised to power 4. So I don't have to expand in this part. So expanding this, I have y squared minus 4y plus 4 plus, here using Pascal's triangle, I have y to power 3 plus 3y squared minus, there should be a minus here, plus 3y, then minus 1 is equal to 2 minus y to power 4. Now let us collect like terms, because we want to make the term with the highest power to be the first term. It becomes y to power 4, because when minus y to power 4 crosses equal to, it becomes positive y to power 4. Y to power 4, the next term is this, plus y to power 3. Then the next term is this and this. Next term is this and this. So I have minus 4y plus 3y will give me minus y. Then the next term is this and this. So plus 4 minus 1 will give me plus 3. So I have plus 3. Now plus 3 will have to go to the other side. It becomes minus 3 plus 2 will give me minus 1. So I have this. The reason I am moving the terms without the unknown variable is because I want to factorize the left hand side. Now if I factorize the left hand side, I have y to bracket y to power 3 plus y to power 2 minus 2y minus 1 is equal to minus 1. Now minus 1 can be written as minus 1 times 1 or 1 times minus 1. What I will need to do, instead of factorizing this polynomial expression, is to equate each terms in the left hand side to each terms in the right hand side. So I will start with this. I'm saying that y is equal to minus 1 first. So if y is equal to minus 1, if I back substitute minus 1 for y in the original polynomial here, I'm going to get minus 1. And if that's the case, let us check if this is a solution to this equation, or if this will give us a value of x that is a solution to this polynomial expression or equation. So we have, if y equals to minus 1, then x plus 3 is equal to minus 1, and x equals to minus 3 minus 1, which is minus 4. So x equals to minus 4. Let's see if we have a balanced equation when we substitute minus 4 into the original equation. So I have minus 4, which is this, plus 1 squared plus minus 4 plus 2 raised to power 3 equals to 2 minus bracket minus 4 plus 3 raised to power 4. Minus 4 plus 1 is minus 3. I have minus 3 squared here, plus minus 4 plus 2 is minus 2. Minus 2 cubed. Then 2 minus 4 plus 3 is minus 1 raised to power 4. This is 9 plus minus 8, because minus 2 to power 3 is minus 8, is equal to 2 minus 1. So 1 is equal to 1. That means that is a solution. We need 3 other solutions because we have a polynomial expression or equation to power 4. Now, how can we get them? It's still by proceeding the way we got the first solution. So I'm going to equate y equals to 1. So if I say y equals to 1, that means x plus 3 is equal to 1, and x equals to 1 minus 3, or x equals to minus 2. Is minus 2 a solution to the original polynomial expression? We can find that out by substituting minus 2 where we see x in the original expression. So I have then 2 minus 2 plus 3 is 1. I have 1 raised to power 4. So this is 1 is equal to 2 minus 1 is 1. Therefore, x equals to minus 2 is another solution. So I have two solutions. X equals to minus 4 and x equals to minus 2 as two solutions to this equation. And we can see that both solutions are whole numbers, even if they are negative whole numbers. The condition is that x is a member of the set of integers. So these solutions are solutions to this polynomial equation. Let's now find other solutions, and we can do that by equating this part of the equation, this bracket, to either minus 1 or 1. So let's start with 1. So if we say y to power 3 plus y to power 2 minus 2y minus 1 is equal to 1, then let's move this one to the other side. So y to power 3 plus y to power 2 minus 2 is equal to 1 plus 1 is 2, because when this crosses it becomes plus. So I have plus 2 here. There is a y here, please. Let us factorize y out. If we factorize y out, we have y bracket y squared plus y minus 2 is equal to 2. Now we can find the other one by just doing what we did earlier. So here y equals to 2. If y equals to 2, x plus 3 is equal to y is equal to 2, because y is 2. And then x is equal to 2 minus 3, which is minus 1. Is minus 1 a solution to this equation? We can find that out by substituting minus 1 into the original polynomial expression. So I have minus 1 plus 1 squared plus minus 1 plus 2 cube is equal to 2 minus 1 plus 3 all raised to power 4. Minus 1 plus 1 is 0. Then minus 1 plus 2 is 1. 1 to power 3 is 1. 3 minus 1 is 2. 2 to power 4 is 16. Now 2 minus 16 is minus 14. So x equals minus 1 is not a solution. Since we now know that y equals to 2 is not a solution, or x equals to minus 1 derived from y equals to 2 is not a solution, let's now try the bracket. So y to power 2 plus y minus 2 is equal to 2. And y to power 2 plus y minus 2 is minus 4 is equal to 0. So let us check if the discriminant will give us a perfect square. B squared minus 4ac is the discriminant, and then b is 1, that is 1 squared is 1, minus 4 times a is 1, and c is minus 4. Then 1 plus 4 times minus 4, 4 times 4 is 16. I have 17. I can't factorize this because I don't have a perfect square. Because I don't have a perfect square, that means the solution, the two solutions from this equation will not be whole numbers. Therefore, whatever value of y we will get after factorizing, this part is not a solution, so we will reject this. There's no need to solve this quadratic equation since this will not give us a whole number after solving it. So what then should we do? We now need to check y squared plus y minus 2 is equal to 2 times 1. We've tried for 2. Let us try for 1. So y squared plus y minus 2 is equal to 1. Because 2 times 1 is 2. Now, y squared plus y minus 2 minus 1, which is minus 3, is equal to 0. Let's now check the discriminants here. We are going to use b squared minus 4ac as we did in the first case. Now, b is 1. B squared is 1 minus 4 times 1 is 4 times minus 3. Now 1 plus 4 times 3 is 12. Again, this solution will not give us a whole number. Therefore, whatever solution we are going to get from substituting the values of y for x, it will not give us a solution. So this is not also a solution. Earlier, we equated the brackets to 1. So let us equate the brackets to minus 1 and see if we get a solution that met the condition, which is x is a member of integer. So y to power 3 plus y to power 2 minus 2y minus 1 is equal to minus 1. And so y to power 3 plus y squared minus 2y is equal to 1 minus 1 is 0. If I factorize y out, y squared plus y to power 1 minus 2 is equal to 0. Now, y is equal to 0. Is it a solution? If y is equal to 0, x plus 3 is equal to 0, and so x equals to minus 3. Now let's substitute minus 3 for x in the original polynomial. That is minus 3 plus 1 squared plus minus 3 plus 2 to power 3 is equal to 2 minus 3 plus 3 raised to power 4. Minus 3 plus 1 is minus 2. Minus 2 to power 2 is 4. Minus 3 plus 1 is minus 1. To power 3 is minus 1. And 2 minus, this is 0 raised to power 4.